So where we left off last week, so this is what we did last week. We were factoring these things. And what you were looking for last week is that whether this had a leading coefficient of 1. And if it did, we said that we can try to factor it in a certain way by splitting it up into two binomials. Now, how did we do that last week? Last week when we did this, how did we do it? Yes, ma'am?
Choose the factor of 15 and 5.
Wait, hold on. I'm kind of confused. So wait. Okay, we got too many voices. Okay, so we're looking for the factors of 56. So factors, things that are multiplied, that also add up to be positive 15. So which numbers would those be? Okay, so we know that 7 and 8 are our two numbers. One is a positive 7, the other is a positive 8. So when we take this x and we split it up, we get an x here and an x here, and we get positive 7 and positive 8. That is how we factored those last week. Now we're going to learn some new methods today. But we also ran into situations like this, where we went to factor them, we split them up, the two x's, and then we said, okay, well here is 12 right there, that like two numbers that multiplied to give me 12 that will add up to negative 4. So what are my two numbers? Do what? 2 and 6. Okay, so 2 and 6. 2 times 6 is 12, but 6 plus 2 is 8, so not that group.
So negative 6?
Okay, so we get negative 6 and positive 2. Negative 6 times positive 2 is a negative 12, so not that one.
They both need to be negative?
Okay, let's try them both. Negative 2 and negative 6. Negative 2 times negative 6 is positive 12, but negative 2 plus negative 6 is negative 8, not that group. Okay, 3 and 4 is a possibility. 3 times 4 is 12, but 3 plus 4 is 7, not that group.
Negative 3. It's not going to equal.
So I'm hearing enough voices saying it now. This one is, there are no numbers that are going to multiply to give me 12 that will add to negative 4. So what is that word that I write in this scenario? Prime. It's not, there is no scenario that's going to work out that way. This is the situation where it's prime. Now we're going to run into situations that are prime today too, but we're also going to talk about a new type of factoring. Okay, so before we get into this, all of today is all about factoring perfect square trinomials. Let's talk about perfect squares because you've learned about perfect squares. There are numbers that are considered perfect squares. Like what are some of those numbers? 4 is a perfect square because of why? What is it equal to? Like 4 is the same thing as what?
2 squared.
It's 2 squared. What other numbers are perfect? 16 because it is the same thing as? 4 squared. Any others?
9.
Okay, 9 is 3 squared. These are all perfect squares because each number can be represented as something squared. Well, now we're going to be talking about trinomials that can be represented as something squared. So here is how we're going to recognize these things. First of all, I want to start off on D. So I'm going to start down here at D. Now, but the one thing that we're going to have to look at first is that we've got these two equations. We're going to be looking at this one and this one. So we're going to see some samples that might look like this, or we're going to see some samples that might look like this. Now, here's the difference between these two. If you looked at those underlined things, the two things that I underlined, what is the difference between those two? Yeah, one of them has a positive here, and one of them has a negative there. Other than that, they are exactly the same. But if you notice that when we have the scenario that has a positive, it ends up being a plus b times a plus b. When we have the scenario that has a negative, it ends up as a minus b times a minus b. Just something to think about because I'm going to show you what this all means in just a second. All right. When we do this, there's a couple things that we're going to need to do. We're going to need to look at these, and we are going to look at the very first thing and the very last thing. Now, I noticed something very special about those, especially with the last number. The last number is definitely a perfect square. But actually, the first one is a perfect square as well. So let's talk about this. 9x squared is a perfect square, meaning there is something times itself that will give me 9x squared. What is that something? 3x. Okay? And 16 is a perfect square, meaning that there is something times itself that will give me 16. What is that? 4. So here's what we're going to do. Is somebody spraying something in here? It smells very chemically in here. I don't know what that is. I don't know what that is. Anyway, so we've got, in this case, we are looking at this scenario that we're going to break these down. We are going to take that first thing, the first term, and take the square root of it, and that will be what we call a. This is going to be our a right there. It's 3x. And the last term that we've got there, we're going to take the square root of it, and it's going to be b. These are the two things that we're going to need right there. We're going to take the square root of the first thing and the square root of the second thing. And both of these, I'm sorry, not the second thing, the last term. So the square root of the first term, the square root of the last term. So when we're looking at these, we see, oh, well, those broke down very nicely. I'm going to scroll up and look at the equation again. It says that if you know a and b, you can just plug it into this formula. And when you do, it's going to be very easy to factor because if you know a and b, you can just plug it in right here. Let me show you what I mean. It says that a squared plus 2ab, oh, I'm sorry, we're using the one that's got negative in it. I put a plus when that should be a minus. Notice that this has a minus here, so I'm going to put a minus. Plus b squared. Now, what's very important here, when we do this, there's really 3 steps that we have to look at. Number 1, we have to find a. Well, we did find out what a was. We took the square root. Second, we need to find b. We did find b. We took the square root. And the third step that we need to do is we need to check it. And here's how we do that. I'm going to take that a and b, this a and b over here. Let me just color code them. Here's a is equal to 3x, and b is equal to 4. And I'm going to plug them back into this equation to see whether this is even a possibility that I can do this special form here. So I'm going to plug them in. So I've got a is 3x, and they told me to square that. Notice it said take a and square it. So I took a, and I'm squaring it. Minus 2 times a times b plus b squared. So here's what we need to do. If we're going to use this special method of factoring, notice that the leading coefficient is not 1 here. I can't do that thing where I look for 2 numbers that multiply to give me 16 that add up to negative 24. That's not going to work here. We need something else. So I'm going to go ahead and check to see whether this, ooh, that is not a highlighter, whether this is exactly the same as this. If these two things are exactly the same, this method will work. So what is 3x squared? It's 9x squared. Remember, both of those things are getting squared. And then what is negative 2 times 3x? Negative 6x. And what is negative 6x times 4? Negative 24x. And then finally, what is 4 squared? 16. Now, here's why. I'm showing you something right now that you have to check, because you'll see in another later example that this doesn't work in every example. Notice that these two things are exactly the same. Would you agree that they're exactly the same? Okay, so what it means is that now that we know that by looking up here, it tells me that if I want to factor this, I just need to write a minus b times a minus b. And that is the factored form once I plug in a and b. What is a? 3x. Minus, what is b? At times, what is a? Minus b, which is 4. So this one works out to be, its factored form is 3x minus 4 times 3x minus 4, which we could also write as 3x minus 4 squared. Something times itself, right? That's 3x minus 4 times 3x minus 4. That's 3x minus 4 squared. Don't worry if you don't get this right away, but you do need to be writing this down. Some of you are not writing this down. I'm not really sure how you're going to get it. Yes, sir?
So the reason why I have to check it is because it's not always going to...
Right. My last example I'm going to show you, you'll see that we could go forward and do all the steps, but it doesn't work in that scenario. I'm going to show you that scenario, and it'll be the last one we see. So all of these, bear with me, because you're going to be like, why are we checking all these? They all work out. The fourth one will not. I'll tell you that right ahead, so you'll go, okay, this is going to work in 3 out of the 4 scenarios. Yes, ma'am?
So what are the requirements in order for this, like to do this method?
So what I'm looking for, like she's saying, what are the requirements? It's a really good question. How did you know to use this? I see that this is a perfect square and this is a perfect square. If the first term and the last term are a perfect square, this is a great method to do. However, there is a check that you have to do. Because notice I'm only paying attention to the first and the second term, whereas that middle thing is still a part of it. I need to verify that that middle number still matches. If that middle number does not match, then this method will not work for us. All right, so here's what we're going to do. We're going to go on to C. Notice that this is a perfect square, and this is a perfect square. So to find A, which is the first step, remember find A, I'm going to take the square root of that very first term, the square root of 4x squared. What is the square root of 4x squared? 2x, meaning 2x times 2x will give me 4x squared. I'm going to do the same thing for B. The square root of 81 is equal to 9. So now I know that A is equal to 2x and B is equal to 9. I've got my A and I've got my B. Here's a plus, so I'm going to use my formula because now I have to check it. A squared plus 2AB plus B squared. I'm going to plug in A and B as much as this seems ridiculous, and it's going to be the step that people will fail to do because they don't think it's necessary. It's certainly necessary, as you'll see on our fourth example, because I'm going to plug in A, which is 2x, and it told me to square it. Then I'm going to take 2 times A times B, and B is 9. And then finally, we've got 9 squared. Yes, sir. Yeah, so your first term is always going to be A, and your last term is always going to be B. Yes, ma'am?
So we need to know that formula, right?
Yes, but now the difference between this and the other formula is not much, is only this. That's the only difference between the two formulas is that plus there. And since this one had a plus, that's why I went with the plus one. If that had been a minus, I would have gone with the minus one. Yes, ma'am? That's right up here. We had that right there. Those are the two things we underlined and said we were going to use those two red lines there that are underlined. So that's basically what we're working with today are those two formulas. Yes, ma'am? Oh, sorry.
So if I were to take the test, you would have the form on top and you just use that as a model.
If you use what?
Like if you have this on a quiz, right? You'd have like let's say A minus B squared on top.
I wouldn't give you any of that. I would give you it just like this.
Okay.
And you would have to figure out what is the best way. I'm not going to tell you how to factor it. You have to know, we're going to keep learning more and more ways to factor things, and you're going to have to kind of go, well, which one works best in this scenario? And that goes back to Bella's question of how do I recognize it here? And this is a great one to use because I see that I've got a square number here, a perfect square, and I've got a perfect square there. It's kind of the perfect scenario. Yes, ma'am?
Will the A's and B's always be kind of like positive ones and then maybe negative is the middle term?
Well, yes, because if you square anything, it's going to end up positive. Now, there are ways to deal with it later on if it's not positive, but we'll deal with that later. Okay, so let's just double check this to make sure that this is this exact same equation. So we've got 2x, and then we are squaring that. What does that end up as? 4x squared. Now we've got 2 times 2x times 9. 2 times 2x is? 4x times 9 is? 36x. And then finally 9 times 9. Is this the exact same as this? Yes. So this method is good to go. So what it says there is if you looked back up at that formula, it tells you that this is exactly the same as A plus B times A plus B. So all I'm going to do is plug it in there. What is A? 2x plus B, what is B? Times A plus B. I've got 2x plus 9 times 2x plus 9, which is the exact same thing as 2x plus 9 squared. Which part?
Wait, then why did you plug it in?
We have to plug it in because this is the part I keep saying, is that in the fourth example, you're going to see that if we don't check them all, there are certain situations that will not work. And how you identify which ones won't work is because when you plug it in, it will not work. Like they don't end up as the same thing. If you notice here, this ended up exactly the same as this. That means go for it. You're good to go then. If they check out to be exactly the same thing, then you are good to go. Yes, sir.
So you're answering with 2x plus 9 squared.
Yeah, I take 2x plus 9 times 2x plus 9. That is the same thing. Imagine we wouldn't leave it just like if we had x times x, that's x squared. You wouldn't leave it like that's something times itself. It becomes that squared. Yes, ma'am.
What if you can't factor them out?
That's again, you guys are playing the what if scenario. Let's get to those what ifs. Let's do with what we've got now. So let's get to the other scenarios in a minute. So I don't want to play with like other examples yet because we're not there yet. All right, I'm going to go to B. Now, I'm going to tell you, first of all, I'm going to do B in two different ways. And I'm going to tell you that the first way I would do it is not the way that we are doing it today. This is a super easy one to factor because when I'm looking at this, I did not think of, the first thing I thought of was not that these are perfect squares. What was the first thing that I was thinking of? Yeah, we're going to factor it like we did yesterday. I saw this. Oh, that's fantastic. I love that way. So when I see that, I'm thinking, well, I need two numbers that multiply to make 9 that will add up to make 6. Are there two numbers that when I multiply will give me positive 9 that when added together will give me positive 6? Positive 3 and positive 3, which means, now granted, I'm doing this two ways. That means that this will equal x plus 3 times x plus 3 because both numbers were 3, which is the same thing as x plus 3 squared. Now, I'm going to do this a second way. Some of you might look at this and go, oh, well, this is a perfect square. 9 is a perfect square, and x squared is a perfect square. Do we agree with that? Okay, so I'm going to do the exact same thing. The answer will end up the exact same way, so understand all I'm doing for this is a second way. So that was way number 1, right there.
I just am confused. Like, what are we looking for?
We are factoring. Like it's when you do this, if I say factor this for me, I'm looking for two numbers that multiply to equal 54. When I say factor this, I'm looking for two things that multiply to equal x squared plus 6x plus 9. That's it. Which two things multiplied to make that? That's what we're looking at. All right. So here's the second way. I am going to find a. And remember, to find a, I take the first thing and I take the square root of it. What is the square root of x squared? Just x. I'm going to do the same thing for b. I'm going to take the square root of 9. What's the square root of 9? Good. I do still have to check it. Now, you and I both know, because we did it the other way, that this is going to factor very nicely into a perfect square. We already know that. However, what if we didn't? Because this is kind of the easiest scenario. But let's look. We've got a squared. Now, notice this one is a plus. So I'm going to use a squared plus 2ab plus b squared. This is just my checking step now. Because in the next example after this, it is not going to work for us. So we've got a is x squared plus 2 times x times 3 plus 3 squared. Riley, hook me up. What's x squared? What is x times x? X times x. X squared. What is 2 times x times 3? And then finally, what is 3 squared? 9. Now look, this one ended up exactly like the other one as well, which means both methods will work. And this one, in the second method, says, well, since this one was a plus, I can just do a plus b.
You want us to do all these methods?
No, I'm just showing you that there are different methods, because what I am going to give you is just a polynomial, and I'm going to tell you to factor it. And you're going to know so many different kinds that you're going to know which one applies to which. Which one am I allowed to use here? And you need to know the different ways. Joe?
If you could just like look at one and say like for number 3, you could just look at it and be like x plus 3 squared. And just put it on the test, we like mark that.
I want to see the work for it for sure. Okay. Finishing this one up. What is A? What is B? What is A? What is B? Okay, so we end up with x plus 3 squared. The same thing we already knew the answer was, but these were two different ways of getting the exact same answer. Now, this is what I'm saying. If it were me, I wouldn't have done the second way here. You know why? Because when I see a 1 out front, I know that's super easy. Super easy. Now I'm going to do A two ways as well, and it's going to fail both ways. Both ways it's going to have an issue. So let's start with what we did yesterday, and that's the way that everybody kind of really liked. We see a 1 out front, right? So let's do this. Let's break it up. I'm going to take that x and put one here and one here. Now I need two numbers that when multiplied will give me 4, but when added will give me -8. Okay, +2 and +2. 2 times 2 is in fact 4, but 2 plus 2 is not -8, so not that one.
It's not gonna equal.
Okay, so if we're saying it's prime, we're saying that there are no numbers that multiply to give me 4 that will add up to -8. Do we agree with that or disagree with that? Okay, so I would agree with you that there are no numbers, and doing this yesterday's way, we would have found out that this was prime. That is a total okay way to do it. But I'm going to show you another method, today's method. Yes, ma'am?
Let's just say we did put 2.
I don't want to change the numbers. Like if you put 2 there, that wouldn't work. You'd have the completely wrong answer. It would be like saying 6 plus 5 is 30.
So if you see that you have the wrong answer, if it's not the same, that means it's prime.
Sorry?
If it's not the same as the word you did, then it's prime.
I'm sorry, I just don't know what you mean.
Like, I didn't know it was prime or not, and I did the work, but it's like different.
Well, but you shouldn't have gotten past this step. If you got past this step, I'm not sure how. Because we needed two numbers that multiplied to make 4. And even if we use 2 and 2, they don't add to make -8. So those numbers wouldn't work. So we all kind of ran into the same scenario where we said, well, what are the two numbers that multiply to make 4 but add up to equal -8? And we all ran into the same dead end. We're like, I got nothing. So we go with prime. But now here's the other scenario. I'm going to do this the other way with the A's and the B's now. Okay, so I see that this one has a minus here. So that means it's going to be this one. A squared minus 2ab plus b squared. The only difference between the two equations I'm using is this negative right there. All right, I need to find a. I'm going to take the square root of what to find a? Of x squared, the very first term. That's this right here. That's the first term. X squared. What is the square root of x squared? Is x. Now I need to find the square root of b. What is b? Like which one are we putting underneath there? 4. So here is what I'm putting in there for b. So that's going to be a 4. What is the square root of 4? 2. Now, we know our a and we know our b, but I need to check this. And this is what I'm talking about. Like you might be like, oh, well, let me try the other method. Maybe that will help me factor it. And we're going to see now what happens. I am going to check this. So it says take a squared. Well, here is a squared minus 2 times a times b plus b squared. Well, what is x times x? X squared. And then what is -2 times x times 2? -4x. And then the last one, 2 squared? So why do I feel like this one is not going to work? This is not the same thing as that. These are two totally different things. And that means this second method will not work either, so don't go for it. This is definitely prime. What I mean is that it didn't matter which route you took here. As long as you did your math correctly, you're still going to end up as prime. It is not factorable by these methods that we know now. Now, we're going to get into some things, and you're going to wish you could go back to these days where you didn't know the things that you are going to know soon. But all we can say now is prime. Yes, ma'am.
If it doesn't work for one, it's not going to work for anything, right?
For what we know now, yes.
So it could in the future?
I remember that, like some of you learned that quadratic equation, -b plus or minus the square root of b squared minus 4ac all over 2a. If you haven't learned it yet, you will, and you are going to miss the days where you didn't know it. So it's one of those things that it's a big equation. Most people don't love doing it, but actually it handles every single factoring situation in the world. It is one equation that will deal with every piece of factoring in the world. Now, it may not always end up pretty, but it'll always solve the problems every single time.
So we have to tell you which one worked for us?
No, I just need to see what you did. But let's say you took the first method and you put two numbers up there, like you did 2 and 2, that would just be incorrect. That's why you have different ways of checking these.
So for each problem, we don't have to do all 4.
Now, I'll tell you this. For this one, you had two options of checking it. For this one, you did not have two options of checking it. That did not have a leading coefficient of 1. So when it has a leading coefficient of 1, we can do something else with it. But for like C and D, there weren't other options. For A and B, there were other options. Yes, sir?
What was the name of the equation you were just talking about?
The quadratic equation. You don't need to worry about it yet. We're going to get into that. Trust me, you'll enjoy these days of not knowing it yet.